Hey, we're back with quadratic transformations. So when we talk about a quadratic transformation, we're talking about the quadratic parent function, which makes a parabola, y equals x squared. So this is really important that you understand and know what the quadratic parent function is. Y equals x squared. Everything that is added to, subtracted from, whatever, to this is what's going to make it change a little bit. So remember, you talked about transformations before. You have a translation, it's a slide, a reflection, and then you can have a stretch. We don't have necessarily a rotation here, but we do have a stretch or a shrink. And so this actually can apply to all functions. There's a parent function for every function, and you learn what that does as far as transformations and how that happens. So we're just looking at quadratic, and we'll look at linear maybe a little bit later, but right now just quadratic. So the parent function for quadratic for a parabola is y equals x squared. That's the base. After that, then things start to change. So if you look at a reflection, that's going to be, you'll notice that you have this negative out front. That's what makes your quadratic flip over the x-axis, and then it opens down essentially. So that's something else that you could say is that it opens down. That's a wording I've seen in trying to compare these. A shift up or down. So I used K here. We'll talk a little bit later about what that is and why that is. But when you have x squared and then you're adding something to the parent function or subtracting, that's going to be a shift up or down. So it's going to be up if you have plus k, that's going to give you up, and then minus k is going to give you a shift down. All that does is take it, shift it up or down. Now then, to shift right or left, we have h. If you do plus h, you would think, looking based on the k above, that plus h would move to the right. It's actually opposite, and it moves to the left. And then minus h moves to the right. So those are backwards. If you can explain to me why that is, then I will give you some extra credit. If you want one that is, if it's going to become wider, you have ax squared, where the a is between 0 and 1. Now we can't just say that it's less than 1, because that would include negative numbers. Negative numbers, the negative makes it open down. So the negative is irrelevant here. So we have a out in front of x squared if it's between 0 and 1. A fraction, more than likely, but a fraction could also be improper, like 3/2. That's bigger than 1. So it's going to be wider if a is between 0 and 1. It's going to be narrower if a is larger than 1. So we're going to look and see what that looks like and how I want you to kind of sort of get this in your head. If you want to, go ahead and graph both parent function and the following function and look to see at the transformation, you're more than welcome to do that. But I'm just going to look at this based on my rules and all these transformations here and kind of tell you what happens to the parent function. So let's look at this first example here. So there's lots of things going on here. You can see that we have a negative here. That means that it opens down, or it's a reflection. And then you have this minus 8 here, which means it's going to be a shift down 8 units. So if you looked at it, a rough sketch of this is going to look like this. So like here's a parent function. The other one is going to look like this. So it's shifted down and opens down. So it's kind of like a man there. But yeah, essentially that's what that would look like. Okay. On this one, this next one, we have 3x squared. So just this 3 right here makes it narrower. So that's what I want you to say. It's going to be narrower. It's actually a vertical stretch. You could say that as well. That's kind of something that later on that you'll talk about. That's going to be a vertical stretch. It's going to make it thinner. So essentially, if we were to, to sketch these two, I have the parent function here, and then 3x squared would be a little bit narrower, closer into the y-axis. Okay, on the next one, that you can see lots of things are going on here. So on this one, you can see that I have this 1/2. I just start with the far left. So that 1/2 is going to make it wider, or a vertical shrink. So a vertical shrink would make it wider. It's kind of pushing down, kind of compressing it. And then the +4 is not right 4, it's actually left 4. So that's this one here. And then the +6 is going to be up 6. So that's this one here. So if I have my parent function, so here's, let's just say this is my parent function. I'm not sure. I mean, obviously it's a little bit off. It's going to be wider, left 4, up 6. So it's probably going to look something like this. Oh, that's right 4. Whoops. So something like that. So left 4, up 6, a little bit wider. That'd be that transformation. And then you have your last example here. So we have this negative sign that's going to make it open down, or a reflection, either one. You can write either one of those. And then this -3 here is going to make it move to the right 3. So if I have my parent function here, so here's my quadratic parent function, open down and right 3, it's going to look something like this. So all of those are the different transformations for the quadratic parent function. This will go along with both lessons. So one video, both lessons, kind of covers everything. So just a good reference is all of this information here. So all of these transformations and kind of sort of what those mean, that's kind of a good reference point. Remember that this is the quadratic parent function. That won't be given to you. You will have to know that. All right, so we have a reflection, shift up or down, right or left, wider or narrower, based on all the things given to me in my function. That's what I have for you for quadratic function transformations.